Today we're going to start in on Chapter 5. Chapter 5 deals with quadratic functions. And today we want to be able to identify a quadratic function, be able to look at a graph and identify different characteristics of it, and then also be able to write the equation given points on a quadratic graph. So in a quadratic function, our standard form is y equals, or f of x equals, ax squared plus bx plus c, where ax squared is the quadratic term. So that x squared is going to identify which one's our quadratic term. Bx is our linear and c is our constant. This goes back to, these linear and constant, goes back to a linear function, if you remember, f of x equals, you may have seen it as mx plus b. We could simply change these this m and this b to a b and a c. So we could write it as bx plus c if you wanted, where bx is our linear term and c is our constant. So as we identify and classify polynomials or functions as quadratic, we want to first be able to expand out the function. So if I look at a, we want to be able to identify it as a linear or a quadratic function, and then identify each of our terms as being quadratic, linear, or constant. So if we look at f of x, we see it's the quantity of 3x minus 1 and quantity times the quantity x plus 2. It looks like it's linear because we don't have the x squared term. However, if we were to multiply this out, distributing your 3x, we'd have 3x squared. 3x times our 2 gives us our 6x. Negative 1 times x, we're going to distribute that negative 1 through as well. And negative 1 times 2 gives us negative 2. Simplifying this, we have 3x squared plus 5x minus 2. And now we have that x squared term in there. So f of x, in this case, is a quadratic function. Our terms, our quadratic term, is 3x squared. Our linear term is 5x, and our constant is going to be the negative 2. In g of x, we have 4 times the quantity x minus 3. If I distribute this 4 into that quantity, I end up with 4x minus 12. Notice we don't have an x squared term. We only have x to the first. That makes this a linear function. So our linear term is the 4x to the first, and our constant is going to equal that negative 12. So the first thing that we want to be able to do today is be able to classify as a quadratic, having that x squared term, or a linear, not having that x squared term. Now I want to go on into the graph of a quadratic function. We call that a parabola. In a parabola, we have a vertex and we have an axis of symmetry. The vertex is going to be identified also, or allow us to figure out if we have a maximum or a minimum value for that function. Our axis of symmetry is a line that divides a parabola into two parts that mirror each other. So if we were to fold the parabola on top of itself, it would mirror one side and the other. The vertex is the point at which the parabola intersects with the axis of symmetry. So our axis of symmetry at this point in time is going to be a vertical line, and the vertex is going to fall on that vertical line. It's going to represent if we have a maximum or a minimum value. So I want to go ahead and take a look at an example of a parabola. Here's the graph of a parabolic function of a quadratic. And we want to be able to identify the vertex and the axis of symmetry and determine if that vertex is a maximum or a minimum. So the first thing I want to do is go ahead and identify the axis of symmetry. Remember, that axis of symmetry is going to mirror or fold this, allow us to fold this parabola in half so that one side looks identical to the other. And if I were to draw a line through this x equals 5, notice that x equals 5, I can fold this graph onto this and it would mirror identical to the right side. So the left side would become the right side, or if we fold it this way, The right side would lay right on top of the left side. So we call x equals 5 the axis of symmetry. Where that axis of symmetry intersects the parabola, at this point right here, is our vertex. So our vertex is going to be at 5, and it looks like 8. And that is our vertex for this graph. And notice that vertex is the highest point this parabola is going to go. So this parabola, the branches we call them, are going to continue down toward negative infinity as we grow to the negative infinity and positive infinity x values. So we say that this vertex is a maximum value. All right, and the last thing we're going to do is be able to write the equation. This is the fun part. This brings back our wonderful 3x3 equations. Ooh, how exciting. So remember, we have the equation y equals, or f of x equals, ax squared plus bx plus c for any quadratic function. Remember, we have an ordered pair here, so we have an x and a y value, and we have 3 of these. So what we can do with this is go ahead and write a system of equations. So we know when y, or 1, or when y is 1, then our x value has to be 2. So we can replace our y with 1 and our x values with 2. So we have a times 2 squared, which is 4, plus b times 2 plus c. And that's one equation. Notice we have 3 variables. If I use the 0.69, I know that 9 is going to equal a times x squared, which is 36, plus b times 6 plus c. And lastly, we know that 0 is going to equal, when x equals 3, a times 9 plus b times 3 plus c. So now we have 3 equations, and we have 3 variables. So just like we saw in systems of equations, we can solve this system of equations and figure out our quadratic function. So I'm going to go ahead and rewrite this just a little bit so it looks a little nicer. We have 4a plus 2b plus c equals 1. We have 36a plus 6b plus c equals 9. And we have 9a plus 3b plus c equals 0. That's going to be nice. What's going to be nice with these equations is that our c will always be 1c, or the coefficient of c will always be 1. So I'm going to suggest that you always eliminate those c values. So remember, we're going to pick 2 equations to start with. So I'm going to go ahead and take my first 2, and we're going to eliminate that c. What we're going to do is go ahead and multiply that top one by a -1. So that gives us 36a plus 6b plus c equals 9. That's my second equation. Multiply my negative through. On the first equation, I get -4a minus 2b minus c equals -1. Solving this system, I have 32a plus 4b, my c's cancel, equals 8. I'm going to do the same thing for my second 2, or I could do the first and the third. Doesn't matter which one we do. Actually, the first and third would be easier because we have a smaller number, don't we? So I'm going to go ahead and take my 9a plus 3b plus c equals 0. Multiply again my negative through to eliminate my c's. So I get -4a minus 2b minus c equals -1. So here I have 5a's plus b, c's cancel, equals -1. So now I have 2 equations, and I only have 2 variables, a and b. So I'm going to come off to the side over here. If I have 32a plus 4b equals 8, if I want to cancel out my b's, I can multiply this equation by -4. And that's going to be -20a minus 4b equals 4. Adding down, 32a minus 20a gives me 12a. My b's cancel, equals 12. So we know that a is going to equal 1. Well, if a equals 1, we can come over here and we can solve for b. We know that 5 times 1 plus b has to equal -1. So we found out a had to equal 1 over here. Solving for b, we can multiply our 5 and our 1, which we get 5. If we subtract 5 from both sides, we know that b has to equal -6. So now we have our a value, we have our b value. Now we can come up to one of our originals to find our c. Doesn't matter, again, which one we use. I'll go ahead and choose my first one there, a little smaller numbers to work with. So I know that 4 times 1, there's my 4 times 1, plus 2 times our b value, which is -6, plus c has to equal 1. Go ahead and solve this out. We have 4 minus 12 plus c has to equal 1. 4 minus 12 gives us -8 plus c equals 1. Add your 8 over, so c is going to equal 9. So our equation is going to be y equals, or f of x equals, our a value, which is 1, x squared, plus our bx, b is -6, so this is actually going to be a minus 6x, and then plus our c value, which is 9. So there's our equation that we're looking for. Y equals x squared minus 6x plus 9. I do have one more equation, one more example if you wish to follow along just to see how that works again. So again, we have our equation y equals ax squared plus bx plus c. We know that each of these has an x and a y value, so we can write 3 equations, one for each point. Our first value, y is going to equal our a times -1 squared plus b times -1 plus c. Simplifying this, -1 squared is 1, so we end up with a. B times -1 is -b plus c is going to equal -1. Our second equation, y equals 3 when x equals 1. So 3 is going to equal a times 1 squared plus b times 1 plus c. Simplifying this, we have a plus b plus c is going to equal 3. And lastly, our last equation, our last point gives us 8, which is our y value, equals a times 2 squared plus b times 2 plus c. Simplifying again, 2 squared is 4, so we have 4a plus 2b plus c is going to equal 8. Now I'm going to go ahead, take 2 equations. I'm going to go ahead and take my first 2 equations. Notice our a's and our b's are exactly the same. So we can go ahead and solve for b if you wish. I know on the last one I said, normally you're going to solve for those c's, or eliminate the c's, but in this case, if we eliminate the c's, we'll also